So this is our demo for the multi-target tracking. So here we have the simulation software, which is called Wireless Insight. As you can see, the reference for the simulation is the Ben Franklin Bridge, which you can see here. And we do have a transmitter and a receiver on the bridge. And in our list of transmitter and receivers, the one called Jammer is going to be our receiver here. That's right here, Jammer. And the one called Infranew is our transmitter. As you can see, both of their antennas are horns, and so if you can look at the pattern of each of the transmitter and receiver, it vaguely resembles that of a horn antenna. And so as you can see here, acting as a radar system where the transmitter will send waves and the receiver try to measure the delay between the transmitter set. Now for the actual target that we're looking at here, we have an object called target 1. Now it's not visible here on this particular bridge scenario, like even if we zoom out a lot and move around. The reason being that it's actually placed relatively far away. So if we wanted to look at it, for example, we can go and enter project view just to see what it looks like. It's placed extremely far away, but this is what the target looks like, right? And even if we zoom out a lot, it's hard to visualize there, but it's placed extremely far away, and it's going to be measured in terms. It's going to be moving around during the simulation. It's going to be moving in a straightforward linear path, but it's going to be measured by our transmitter and receiver to get that delayed time. And so what we go from here, this is our simplest simulation, but we would run the simulation, and it would generate these output files with information on the simulation. So when you run the simulation, you can see that it's running here as well. So this is the initial output from the simulation. However, one thing that we do need to do is we're going to run this through a ray tracing emulation tool. And to do this, the reason for this is the simulated wireless channel data has to be converted to readable data, and usually the purpose of this is to be able to use it with the emulator, but for our purposes as well, we want to do this so we can get the important information that we need to run the simulated data through our tracking filter. So we're going to open Spider here, and I have the information for the run file. It's just using the main processing file for the ray tracing emulation, and this June 14 PFP is an existing JSON file that has configurations telling it where the output files are and such. That I took and edited from the previous design team. And it does take a little bit of a while to run. I can show the start of it, but we'll skip over it for the purpose of time. But as you can see, it's running ray tracing over the wireless channel, and you can see it's completing the iteration number 0 out of 11, and I'll run through and go through. But for the interest of time, we're just going to move on, and we'll move forward with the exported data and continue on the demo.